So let's watch this video first to understand it better. Okay, so this thing is rotor vapor. It's not close to my drawing. I know that, but still tried my best to draw it. Let's wait for a moment. So you can see this thing over here, this thing that is something like this, gives you this type of structure. That is the RB flask. We call it RB flask. So that is nothing but the round bottom flask only. Okay. And the thing you can see like here, over here, this thing is the condenser. So that thing through which the mainly the cooling part is done. Okay, that is the condenser over there. And this is over here. This is the water bath. That let me show you that. It's called rotatory vapor. So you know that is the round bottom flask. You can see like how it looks like. Yeah. So now, yeah, you can see the. Oh, so this is the water bath. Okay, you can see like over here. Yeah, this thing over here, that is the water bath. Okay, so you know, if you just turn on these knobs, then what would happen? The temperature of this water bath would be increasing or decreasing depending on that. Okay, and when the RB flask is just, and this is the machine over here. What's this? That is the thing. It would evaporate your solvent at low temperature. That is the temperature bath. So that thing is the cooler. These knobs are the, if you just spin it, then the temperature would increase or decrease depending on that. Now that thing over there, that round bottom flask that she's touching over there, that is the round bottom flask where the distillated liquid is going to get condensed. You would be able to see everything. So that is the knob through which you can just, you know, move that thing up and down. First, they are just turning on the water. So that is the coolant. Okay, that is the thing that is going to make it for the cooling purpose. Okay. So now this round bottom flask, they are just you know, sticking it together using the clamp. Okay, and making it airtight. Now they're through the clamp, so they are just stuck to each other. Okay, so what's this? So that is full of water. That part, that is the one that is the thing that is going to make it cooler. Now they are increasing the temperature, increasing the pressure, and just putting it down to the water bath. Yeah. So now the water bath is going to give it the heat. Okay. So the water bath is there to give the heat. Okay. You can see how does it work. So it is spinning. Okay. Inside the solvent is there, and it is starting to get evaporated because the pressure is also using there. So the water bath has 45 degrees centigrade. You would be able to see after a moment there would be no liquid. There would be no liquid. Right now you can see that there is something liquid in it. You would not be able to see any liquid inside it. Wait for a moment. So it would take only 1 minute. You can see it has started boiling. They are just turning the vacuum off now. Okay, turning the pressure off. Now they're just trying to take everything out of it. Now, can you see that there is no such liquid inside that round bottom flask anymore, because the entire liquid has been, you know, has been is there in that big round bottom flask. Okay, you'll be able to see that that is entirely solid now inside that RB flask. They're not showing it properly. So the thing is, after after they just take it down, so there was something like this, and there was another RB flask connected over here. That RB flask is going to take the entire solvent. Okay, the entire solvent. Now, and in this RB flask, that was the small RB flask with the red colored solution, that would contain only the solid red colored product. So this is the process through which you can do it fast. You have seen that how quick it was to separate out the distillated and the like A and B, both of them, to distillate that both distillate. Okay, now if I just move on, the next process is called the steam distillation. Okay, this is called the steam distillation. So this is another part of this distillations only. Okay, steam distillation is another type of distillation. Fine. Now in this distillation, what we do is we use steam. We use steam to take out steam to separate. Why do we use it? To separate oils from plants. So through this process, we separate out the oils from essential oils. I should rather say essential oils from the plants. I would show you the video. Steam distillation is a separation process used to purify isolated temperature sensitive materials. So that is a thing, what is happening over here. So you can see in this, if you just look into this video over here, I'll just start it after a moment. So if you just look into that video, you'll be able to see that there is a beaker containing water. Okay, in this video, you'll be able to see. And the leaves, the plants through which you are going to take out the oil, you have to take a jar like this, and over this, you have to take all the plants. And now you have to heat it. So the steam is going to take out the entire oil from the plants, and they are going to, we are going to collect it. Okay, let me show you how it's happening entirely. So you can see this picture first. Just wait for a moment. Just wait for a moment. This is not what you're supposed to see right now. Yeah. See. Yeah, you can see the plants over there, and you can see the water bath over there. So when you just keep on hitting it, what would happen is this water is going to go through these plants. Okay, and now these plants over there contains the essential oils. Okay, and those essential oils are going to get out of the system with the vapors. If you just go through the video, it would be easier for you to understand. So they are also saying the same thing. Most of the essential oils are being separated. 1000 AD. Okay, when this was invented, still this is one of the best ways to take out the oils from the plants. So this is the distilling apparatus. You can see in the reservoir there is some water. So there is another chamber where it holds the natural substance from where you are going to take out the oil. So they are saying that there are so many tiny sacks of oils inside that. Okay, and that things you want to take out. So steam is going up, taking out that oil particles. So now the oil is going along with the steams now. And together they are going through the coolant. This is the condenser, right? And after that, when inside the condenser, it is getting, the temperature is going down and it is becoming liquid. Now in the liquid, there are water and oil, both. Okay. So they are going to get separated naturally. You can see The water was left at the bottom and the oil rises to the top. And if you cannot separate them out with the normal processes, you know what to do. How to separate out oil and water? What is the name of that process through which you separate out oil and water? You remember? Separating funnel, isn't it? That was there in the last video. Okay, so through which you can take that out. So that is what we call the steam distillation process. Fine, clear? Go to the next part. So classification of colloids, lyophilic and lyophobic. Let me tell you what does the word lyo means. So the word lyo means solvent. Okay, let me just write it down. Wait for a moment. Yeah, we're done. Okay. Yeah. So we were here, right? So the lyophobic and lyophilic colloids. So let me tell you what does it mean. The lyophilic. So the word lyophilic stands for lyo means solvent. Okay, lyo means solvent, and philic. Tell me, philic is the exactly opposite word of phobic. So it is the opposite of phobic. What do you mean by this word phobia? You have heard this word phobia for a couple of times. What do you mean by that word? Phobia. It means fear, isn't it? So similarly, phobia means fear. Then philic, it comes from phobic only. Okay, and then philic means love. Okay, so lyophilic means love towards the solvent, which means they are stick together. They're sticking together. So these are the type of colloids. There are the colloidal solution in which dispersed phase. In the particles, dispersed particles have a strong affinity towards the dispersion medium. So as in a solution, if we think about a solution, so in a solution we have solvent and we have solute, isn't it? In a solution. Similarly, this is a true solution, isn't it? This is the true solution. But when we're talking about the colloidal solution, they are not called solute and solvent anymore. They are called dispersed phase. Okay, dispersed phase and dispersion medium. They are called the dispersed phase and the dispersion medium. So they are just they are just the same like solute and solvent. So dispersed phase is just like the solute, fine, and dispersion medium is also just like the solvent only. Got my point? Now this was all about the colloidal solution. So when, just think about it, let's consider milk and water. Okay, let's consider milk and water. So this is exactly a very good example of lyophilic colloidal solution. So what happens is, if you just take out the water like this, and if you mix a few amount of milk in it, right? So what would happen? The milk particles would get entirely dissolved in water. If it gets entirely dissolved in water, but still it is just like a translucent type of solution, isn't it? translucent type solution. You are going to get a translucent type solution. I agree to that. But the thing I want to say is the particles are completely, dissolved in water. The particles are completely dissolved in water, isn't it? For a moment. Yeah. So the colloidal particles, you're understanding it? They are completely dissolved in water. Dissolved in water. But what is happening for a solution of oil and water? So when you are mixing out oil and water, okay, and you are just stirring it, okay, with the help of a little bit amount of detergent in it, what would happen? If you just don't give detergent, what would happen? That would be a colloidal solution, oil and water. If you just mix it very, stir it for a huge time, then what would happen? It would give you a type of a colloidal solution, isn't it? But in that colloidal solution, the solvent and the solute won't mix together. In that colloidal solution, solvent and solute won't, so we cannot say solvent and solute for the colloidal solution. We can say dispersed medium and dispersed phase. Okay, they do not mix together. They remain like this. If you just take a water like this, over there, the oil would be floating like this, isn't it? So that would be the oil, and the thing over there would be the water. This is the thing you are going to get, and we call this type of solution as lyophobic, because the particles of the solute or the dispersed phase have a phobia towards the solvent. Lyo means solvent. Got my point? So that is called lyophobic salts. So let's see. So lyophilic salts are just like starch, gum, gelatin. All of them are lyophilic salts. And when the dispersed phase has no affinity for the dispersion medium, they don't mix together. That is why we call it lyophobic salts. Clear? So if you just add some detergent in a lyophobic salt, what would happen? It would get converted into lyophilic one. Because when you add some detergent into a oil water mixture, what would happen is the entire oil would get dissolved in water. And we would come to that point, why is it getting dissolved? That's a very interesting phenomenon happening over there. Okay, so I would get to that point. For now, I can tell you detergent is just like, this is the hydrocarbon chain. Okay, inside a detergent, and this is the polar part of detergent. Okay, and the hydrocarbon chain is always non-polar part. You don't need to understand all of this. So what I'm trying to tell you is, inside detergent, one part is lyophilic, another part is lyophobic. This polar part over here, this one is lyophilic, and this non-polar part over there, this one is lyophobic. Okay, so if you add some detergent in it, something happens. I would just come to that later. So if you just keep on watching my videos, you'll be definitely understanding it. So if you just add some detergent in it, what would happen? The oil and water would get mixed together. This is the mechanism through which the detergent is taking out the stains from your cloth and all. Okay, so this is how it takes that out. Clear? Got my point? Okay, now you can see over there, they are trying to show you that thing only. So this is the detergent. Okay, you can see over here, this is the ionic part of detergent. Okay, and this is the hydrocarbon chain. They have tried to show you that only. Hydrocarbon chain. This hydrocarbon chain is non-polar. Okay, so you can see what is happening over here. as this is the oil. This is the oil. Okay. What is oil? I have told you earlier as well in my earlier videos, oil is a fat. Oil is made up of fatty acids. Okay. Oil is made up of fatty acids, and the fatty acids are made up of hydrocarbons again. So basically oil, what is oil then? If it is made up of hydrocarbons and fatty acid, then what is oil? Oil is also non-polar, isn't it? This is also non-polar. Now what would happen? So in detergent, you can see the non-polar part. This part is connected to the oil. So the non-polar part is connected to the oil. So this non-polar has an interaction. So this part is connected to the oil. And the head, which is ionic, which is polar, that is exactly in the opposite side. This is dissolved in water. Try to understand it. If here I have a stain over here, okay. Now, if you're using the detergent, the detergent's hydrocarbon chain, the detergent's non-polar part would get attached over here, and the rest of the detergent would get dissolved in water. Okay, and this stain and this non-polar part won't get dissolved in water. Now, but they have a very good interaction over here. Now, when you are just washing that water up, when you just draining the water, what would happen? When you are draining that water, what would happen? This part is water soluble. Try to understand it. This part is water soluble, and this part over here, this is fat soluble. So it is getting connected with the oil in my shirt. This is the oil in my shirt. Okay. Now this is with the water in the bucket. This is with the water in the bucket, this part. And this part is with the oil. Now, when you just drain that water down, what would happen? The water would take up this head with it, and this head would take up this tail with it, and this tail would take up the oil with it. So when the water is getting drained out, the entire detergent and the oil together are going out of the system. Clear? That is how detergent works. Okay. So, we are in class 10, you are going to learn about it in more details. Okay. Now, application of colloids. A colloid is used to as a thickening agent in industrial products such as lubricants, lotions, toothpastes, coatings, etc. Okay. In the manufacture of paint and inks, colloids are useful. So basically, paint and ink, ink is like a true solution, but paints are, this is the colloidal solution. Okay, the paints are already colloidal solution. Okay. Now let's come to the FAQ. So it's like we have come to the end part of this video. So what is the major difference between lyophilic and lyophobic salt? I think you got this far. Okay, about got it so far, right? Lyophilic are the salts to have that strong interaction between that dispersed phase and the dispersion medium. Okay, and highly stable and resistant to coagulation. Okay, now to understand that, you need to know what is coagulation, right? So what is coagulation? So coagulation is a method where the colloidal particles gets mixed together to form larger colloidal particles. So that it's like small colloidal particles are getting mixed together to give you a big particle. And when the colloidal particle inside a solution, they are getting mixed together. When the colloidal particles are mixed together to give you a big particle, what would happen? It would sediment it down, isn't it? It would become a suspension. The entire solution would become a suspension. So coagulation is a road through which a colloidal solution goes to suspension. Fine. Now, lyophobic salts are unstable, weak, and the van der Waals force of attraction between the dispersed phase and dispersion medium is due to these force. These are irreversible and ready to coagulate. Okay. So the thing is, lyophobic salts, they have no interest towards the solution. So they try to coagulate and they try to, get down. They try to get precipitated. But on the other hand, lyophilic salt, they have a very strong interaction towards the solvent. So they just don't want to, make bigger particles and go out of the system. They just don't want that. They want to stay there inside the solution. That is the major difference between a lyophilic and a lyophobic salt. Okay. And now, what are gels? Gels is a special type of gel. This is that gel only that you apply on your hair. Okay, that is that gel only. So what is the gel? The gels are the type of salts. Now, what are the salts? So you can say gels are the types of colloidal solution. Colloidal solution. Look, there are so many colloidal solutions. Okay, there are so many colloidal solutions. Okay, like sol, like gel, like foam. What else? Aerosol. Okay, there are so many things. Okay, solid sol, liquid sol. There are so many things. Okay, sol are those type of particles where the dispersed phase, that is solid. When the dispersed phase is solid, we call it a sol. Okay, gels are the type of salts. So for gel, the dispersed phase is solid, which solid in which solid is the dispersion medium and liquid is the dispersed phase. Okay, yeah, I was just writing it all wrong, right? Over here, dispersion medium. Yeah, so dispersion medium, I mean the solution. What I mean to say is the solution, the solvent. Okay, so dispersed phase, and dispersed phase is the solute. Dispersion medium is the solvent, right? Okay, now that was the thing. So where the dispersion medium is liquid, solid, and the dispersed phase is liquid. Okay, so it's like in the solid, the liquid is there. Okay, generally we see the liquid, the solids are inside the liquid, but in case of gel, okay, the liquid is inside the solid. Getting my point? When you are dissolving sugar in water, you are dissolving sugar in water. Water is the solvent and sugar is the solute. Now in gel, what happens is, so sugar is the solid one, right? Water is the liquid one. Now in gel, what happens is the solid is there and you are mixing something liquid in it. Okay, solid is there in higher extent. So that is called the gel. Okay, and these are stable at comparatively low temperature. And you have used gels, right? There are so many gel that we apply on our hair and all these things, right? You have seen like there are so many medicines as well that looks like that only, gels only. And there are so many jellies and all these things as well, so they are gels as well. So this was all the example of gels. And that, yeah, so they are the type of salts where the dispersion medium is solid and the dispersed phase is liquid. Okay, got my point? So that was the last thing for today. Okay, and yeah, so you just keep on going through it again. Okay, we have read so many advanced separation techniques. I think you have understood all of it. Okay, and yeah, that's the thing. That was the end of this lecture. You just keep on practicing the things, and if you have any doubt, what you have to do is you have to just write it on the forum. Okay, definitely one of us would get back to you. Thank you for your attention, and just keep learning from Ask IITians. Bye everyone.